What is up, amigos? The Mini Cooper S is a cult classic car, but it isn't really styled for aerodynamics. So my question is, how aerodynamic is it? And can some new aero modifications change that? As we will see, this current Mini has a pretty bad diffuser, and that is very much just because of its general shape, so it can't be fixed. But maybe one of these new aero devices can change that. If you don't know, a while back we tested the original Mini Cooper's aerodynamics, and you can find that here. And that poses another question too. Is the modern day Mini Cooper more or less aerodynamic? Has it moved in the right direction? Well, we have a model of the regular Cooper S here, and it is going about 70 km per hour. Considering the shape of the Mini, the flow is quite a bit better than I might expect. I mean, the front is blocky, and that isn't great for its aero. The nose is rounded quite a lot, and while that might be good for the local aerodynamics, because the flow stays attached very well here, it results in the hood being very flat, and then that dramatically increases the angle between the hood and the windshield. In fact, if they slope the hood more, it would alleviate that angle more and reduce how much flow deceleration there is. And I actually wanted to say that this region is better than the original Mini, but when I looked at the simulation, it wasn't. The original Mini had a more sloped hood. One major improvement of this newer version is over the roof. The old Mini had a major flow separation region, while the new version has completely attached flow, and that is a major advantage because you have a smaller wake and less drag. The underbody is also pretty good. One thing I really like is the heavily integrated front wheel deflectors. They are a major improvement over the typical flat sheet you just get extending vertically down. By smoothing them, you can better guide the flow where you want it to go. The front lip is pretty good too. It is a little too sharp, but it still helps speed the flow up, as you can see by the red color, and that comes with a lower pressure, which helps reduce the Mini's lift. Something I am surprised at is how angled the flow is, and that is actually a major inherent disadvantage of the Mini's iconic design. So regardless of which Mini version you get, from this Cooper S to the Countryman and so on, they all share this rear geometry where the rear wheels are almost right at the back of the car. That might be great for handling, but it also means that you don't have much of a diffuser to work with. There just isn't any more length to work with. If you even extend the diffuser one more inch, it is no longer a Mini, and that is a scientific fact. And because of that, a regular angle doesn't really do that much, and we can see that in the wake here, where the flow isn't shot up that much. So the wake remains large, which strongly suggests higher drag and even lift. And Mini knows that they have that inherent problem, and that is why they fitted a rear spoiler on the roof, but it still isn't kicking the flow up that much. And I think that Mini didn't go for an even bigger one because they tried to keep the Mini's look. From this top view, which is cutting through at about the driver's head height, I'm really impressed with the flow. It's much better in this plane. The front windshield is rounded, and that might not seem like much, but that also allows the flow to bleed around the A-pillars easier, and you can see that there isn't much blue flow here, so the flow isn't being forced to decelerate as much. The rounded front windshield is actually a strength of the old Mini too, and in fact, that was a major aerodynamic advantage at the time because back then, flat and square windshields were all the fashion. I'm also really impressed with the A-pillars because the flow doesn't separate over them, and that was a major weakness of the old Mini. So it's nice to see that improvement here, but interestingly, we still get quite a lot of low pressure here. That isn't an issue because it only affects the side force, and in a straight line, this force is more or less symmetrical, but around corners it could pose an issue. Now, even though this Mini preserves the boxy shape, the rear is rounded just enough to wrap the flow around the C-pillars and separate quite far back, so the wake shrinks, and that is good for drag. The drag ISO surfaces are also really impressive because they are quite small considering just how square the car is. We get a lot of drag from the front wheels, which is pretty normal, but the drag from the wake is really only around the lower half of the car. The top half is impressively small. Now, one region that could really be improved upon is the side mirrors and even the front side windows. What I think is happening is that the flow from the mirrors is causing drag on the side windows too. So the drag coefficient comes in at 0.35 and the old Mini we simulated came in at 0.37. Now the lift is 8.1 kilos, which isn't great, but isn't bad either. These simulations were done with OpenFoam, and if you want to learn how to use OpenFoam, then take our course here. So that is the baseline version, but there are a couple new aero mod ideas floating around that I'm really interested in, and this Mini Cooper is a great car to test them on. The first mod comes from a paper called Study of the Effects of Vertical Airfoil End Plates on Diffusers in Vehicle Aerodynamics. And the idea of this aero mod in the paper is to add wings at the end of the car. The wings should have the suction surface towards the center of the car, so the low pressure helps suck the flow out. This paper showed that the lift dramatically drops with these wings. Now, I wanted to see what would happen if you flip the wings so that now the low pressure regions were pointing out. On the one hand, you don't get the low pressure sucking the flow through the diffuser into the wake, but on the other hand, you might be able to direct the flow into the wake more around the sides of the car and possibly reduce the wake size. Another thing I wanted to modify is the size of the wings. With this original paper, the wings at the back are very large. They hang past the rear of the car quite a lot, kind of like wearing a t-shirt that's too small to cover your guts, and it just hangs out. So I wanted to shrink these airfoils down so that they are almost completely in line with the end of the car. What is the overall result of this heavily modified modification? Does it do anything good? In this center plane view, I'm a little surprised because they don't seem to be doing too much. I mean, okay, they're quite small, but it's not the size that matters, but how you use it. At least that is what we are led to believe. And peeking from above, peekaboo, the weight close to the car is also pretty much the same. From above, we have this plane cutting through the wings, and the great thing is that the flow stays attached over them. That was actually something I was quite cognizant about when placing them. I wanted to angle them, but not so much that there was a stall, because that would then just produce wakes for no reason. That's what I tell my little cousin. He was just making a wake for no reason. But it seems like this angle wasn't enough for the wings to really do too much. And coupling that with the fact that they are small, they either need to be some kind of multi-element design or larger or a different profile. So on our Patreon, that you can find here, we tested NACA 0021 airfoils, which are symmetrical airfoils, but they are thicker. Looking at the drag isosurfaces, we see a potential problem here, and that is the rear wheels and housings produce quite a lot of drag, and that impinges on the airfoils, so the airfoils have a lot less energy to work with. As such, maybe either a different location or being bigger or a different profile would help tame the chaos. From the drag, it was the same at 0.35, and the lift was also just a touch higher at 8.2 kilos, but that difference is likely within the error of the simulation. So putting NACA 4412 airfoils at the rear of your Mini like this does nothing. If you're interested in how a different profile the NACA 0021 profile performs, then check out our Patreon in the link below. Now that's not the only general modification that has been floating around the last couple of years. Another one is putting a wing just underneath and to the rear of the diffuser. And given the strict geometric requirements of this Mini, this is a viable alternative to help make this diffuser region potentially perform better without changing the diffuser. This is a NACA 4412 airfoil, and it is angled right on the edge between attached and stored flow. So this is really as good as it's going to get from this particular airfoil, and in fact, this airfoil is performing better than it usually would because it is so close to the ground, so the flow is getting squished over this suction side and keeping it attached. The lower wake is definitely helped because you can first of all see how much smaller it is, but also because it is directed a little more up. And I'm actually quite surprised at just how effective it is considering how small it is. That's what she said. From the pressure plot, we get big time low pressure over the suction surface, and actually the high pressure ahead of the wing under the diffuser is actually a pretty good thing because that is flowing onto the pressure side of the wing, and that helps increase its downforce. With this drag orbit, it's hard to tell what effect it is really having because the wing doesn't extend to the sides of the car, so the drag from the rear wheels is just engulfing it. Even from the back, you can't see too much of a difference. Maybe the top half of the car's drag is shifted up a little. Anyway, the drag of this car came in at 0.38, so 30 counts higher than the original. But the good news is that the lift was only 6.0 kilos, so a 25% reduction. So this airfoil diffuser mod does definitely help, and this is just a very simple wing, not a fancy one. The only downside I can really see is that it reduces the ground clearance a little, which would make it harder running someone over completely. And if you're staying on YouTube, YouTube thinks that you'll like this video, so check it out. Peace out amigos.